Microservices architecture is a pattern for organizing computer systems into services that can scale with demand. Back in the 1990s, an internet company would run a big monolithic program on a server that the company maintained on-premise. To serve an increase in traffic, a popular company would simply add more instances of the monolith. Monolithic architectures do have some positive features. A monolith centralizes the codebase, so it is in one place. Engineers can step through any part of the code when they are debugging. Also, user requests that are completely served by a monolith do not have to make many calls across a network, which reduces the chance of network failures. Most software companies have their code in a monolith today. When those monoliths get big, problems can start to occur. Centralized code leads to tight couplings that are hard to break up. If a program is too big, it will be impossible to run on a typical machine. Internet giants in the early 2000s began breaking up their applications into services. Instead of scaling the monolithic application, a service-oriented architecture could scale the parts of an application that were under load. Operating system virtualization made service-oriented architecture more economical. One server could host multiple virtualized operating system instances, and each of those instances could run a service. But this also meant that engineers had to manage more and more layers of infrastructure. The virtual machine host, the hypervisor layer, and the hardware itself. Failures became more complex. Debugging got harder. In 2006, Amazon Web Services launched the Elastic Compute Cloud. EC2 allows programmers to rent virtual machines in Amazon's data centers. With Amazon taking care of failures at the hardware level and the hypervisor level, programmers could focus on the virtual machine hosts themselves, where their application code was running. But using an entire virtual machine to run a small piece of application code is wasteful. Containers allow a virtual machine to be sliced up into isolated file system regions. A container can be as large as the entire VM, or as small as your smallest service, hence the term microservices. Microservices run in containers, which run on a virtual machine, which runs on a hypervisor, which runs on a server, which sits in a rack, which sits in a data center, which is part of a network of data centers called the cloud. Containerized architecture led to a new problem. Companies that ran thousands of microservices in containers on the cloud did not have a simple way of managing them. Kubernetes is an open source project from Google that gives engineers a centralized system for managing containers. Kubernetes also makes those services portable, creating a competitive tension between Amazon Web Services and Google Cloud Platform, both of which can host Kubernetes clusters. The days of microservices are just getting started. Software development has never been easier, and the two biggest companies in the cloud are competing for users. It's going to keep getting easier and cheaper.